Hello, I'm Bretton, one of our MCAT tutors here at Inspira Advantage, where we help students get into med school and other professional programs. Welcome to our final video on the Hardy-Weinberg Equilibrium. Today, we will go over 3 guided examples in increasing difficulty. Let's jump into it. In a population, the frequency of the dominant allele, A, for a certain gene is 0.8, and the frequency of the recessive allele, little a, is 0.2. What is the frequency of the homogeneous recessive genotype, little a, in the population? Take a moment, see if you can solve this. So the math we need to do, we know that Q squared will give us the frequency of the homozygous recessive. Well, it told us that the frequency of the recessive allele, A, is just 2. So we know that Q equals 0.2. So let's take 0.2 times 0.2. Well, that's kind of hard to do in our heads, right? So let's write this like we would for the MCAT. So let's say we've got 2/10 times 2/10. Same thing as 0.2 times 0.2. Multiplying this out, we get a 4 on top over 100. Well, this is equal to, this is much easier to see, 0.04, or answer choice D. Let's try one more, kind of similar to the last one. In a population, the frequency of the dominant allele, big A, for a certain gene is 0.7, and the frequency of the recessive allele, little a, is 0.3. What is the frequency of the heterozygous genotype, big A, little a, in the population? Take a moment, try and solve this. So again, let's write down what we know. We know that P is 0.7, and Q is 0.3. And we also need to now remember, okay, what is the equation to give us the heterozygous genotype? Well, that is just multiplying 2PQ. So once we have that, we can plug in our numbers. So 2 times 0.7 times 0.3. And let's rewrite this with fractions so it's easy to solve. So 2 times 7 over 10 times 3 over 10. Now let's rearrange this so it's easier. So 2 times 3 is 6. 6 times 7 is 42. So this is equal then to 42 over 100. So therefore, our frequency is 0.42, or 42% of the population will be heterozygous. Now think about quickly, how would we solve for homozygous recessive and homozygous dominant? For homozygous recessive, that equation is Q squared. For dominant, it's P squared. So we would just take those numbers and square it. Q squared, we'd say 0.3 squared. P squared would be 0.7 squared. And this is 0.09, 0.49, respectively. All right, now we're going to kick up the difficulty a notch. A population of birds has a gene that determines feather color. The dominant allele, big F, codes for red feathers, and the recessive allele, little f, codes for yellow feathers. In the population, the frequency of the dominant allele is 0.6, and the frequency of the recessive allele is 0.4. What is the frequency of the heterozygous genotype, big F, little f, in the population? And what is the frequency of homozygous dominant genotype, big F, big F? Take a moment and try and solve this. Again, I think a good first step is to write down what we know. We know that our dominant allele is 0.6 and our recessive allele is 0.4. Now we just need to figure out, okay, what is the equation to figure out heterozygous and homozygous? Heterozygous, as we previously saw, was 2PQ, and homozygous dominant is P squared. So again, we just need to plug in the numbers. So 2 times P, which is 0.6, times Q, which is 0.4. And then for a P squared, this is just 0.6 squared. Again, we want to rewrite this in fraction notation. So we'll say 2 times 6 over 10 times 4 over 10. If we solve this, let's do the 2 times 4. So this gives us 8. 8 times 6 is equal to 48. So we can say 48 over 100, which is equal to 0.48. After solving for heterozygous, let's check to see if we're done. Luckily, we can. It's answer choice C because that's the only one that starts with 0.48. However, let's just double check for the sake of practice with p squared. So if we take 0.6, again, this is 6 over 10 times 6 over 10, same as 36 over 100, or 0.36, which does match up. So we can be confident that our answer choice is C. I hope that these examples were helpful in promoting your mastery of Hardy-Weinberg equilibrium problems. This is a common problem you'll see on the MCAT, so you want to make sure you're able to do it accurately and efficiently for the MCAT. Thank you so much for watching our video, and I'll see you next time.